everybody, it's Miss Phoebus, and I'm back with another video, Lesson 40, Writing and Rewriting Quadratic Equations. Now this one is kind of out of order a little bit. Actually, you're going to jump further ahead in the notes, but I felt like it was a good one to do online, a video, kind of pull some of the graphing stuff together. I know that we're having a little bit of trouble in class with the graphing component. And so what we're going to do is we're going to be looking at graphs and writing equations. We're going to be looking at tables and writing equations. And there are three forms that I taught you in graphing, and I just want to kind of review those a little bit. So there was the factored form. We had something like this. Remember, to graph, you found the zeros first, so you were like, okay, I'm going to make this equal 0 and x equals -1, and for this one I'm going to make it equal 0 and x equals 5, and those are the zeros, right? Well, what we're going to start with today on some of these is we're going to start with this, and our goal is to go backwards, get here, and then multiply those factors together to get it in standard form. So that is one way we're going to write some equations. There's another form, remember our vertex form, where you have something like this. And you know that this is left 3 and this is up 7, so your vertex is at -3, 7. And then the A value does something, it's negative, so there's a reflection, it's been flipped upside down. That slope is not a slope of, up 1, right 1, it's actually down 1, right 2. So that kind of, we're going to pull that from looking at a graph. We're going to look at, where's the vertex? What is the slope from the vertex to that next x over? What is going on? And then can we write an equation? So we're going to be given some different things. To write it in standard form, we're going to use this method to get there. But I also have a method to change this into our standard form, and standard form, of course, being y equals ax squared plus bx plus c. So we have quite a bit of stuff to do, but individually none of them are super difficult. It's using stuff that we have used before. So I should be, by the time we get to the end of this, I should be able to give you a graph or a table and have you write an equation of a quadratic, and then be able to say, hey, this one's in factored form, can you write it in, or standard form, can you write it in vertex form? Be able to give you some different forms and ask you to change them. All right, so here we go. I can write equations of quadratics when given the table, 2 points, or other key characteristics. We need to be able to write functions. Okay, so we're going to write the quadratic in different ways. So we can show zeros, so we can show extreme values like our max or min. And I need you to be able to create equations in 2 or more variables. And that's our equations of our graphs. So we're going to jump to page 181. And on page 181, you see this. When given zeros, you're going to write each zero as a linear binomial, and then you're going to multiply. Now, one thing I'm going to harp on you about is they're telling us to write equations. Equations have equal signs. So if you are just going to jump straight in and give me the x squared plus 5x and plus 6, that's not an equation. That's an expression. We need to be able to write the equation of a quadratic with zeros at 2 and -3. So when we write this equation, I need to see y equals. Now the zeros are given to us. There's 2 of them. And so really this is like when we were factoring and we were solving by factoring. They're giving you the answers. They're telling you x equals 2 and x equals -3. But that's not what I want. I want these guys to go back inside parentheses. So I know that I'm going to have an x in each parenthesis. But I need to get this 2 to go back over and hang out with x. It's kind of the backwards of what we've been doing. We want that 2 to join the x. We want this -3 to join this x. And so remember that when we were solving, I said a lot of times we can look at it as opposites. So to bring that 2 back over to hang out with x, you could subtract 2, or I see a positive 2. The opposite of positive 2 is negative 2. So the goal is to get that number back into the parentheses with x. So if I have x equals negative 3, what is that going to look like in my parentheses? The opposite of positive 3, the opposite of negative 3 is positive 3. And then I'm going to put a y equals in front. Now, I want you to give these to me in standard form. So that means that here's factored form. I want you to multiply them together. So another multiplying practice thing. So x times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And so my final equation is y equals x squared plus x minus 6. So you are doing the backwards. When we're solving, we're trying to take the equation that looks like this and figure out where the zeros are. Now I'm giving you the zeros and I'm asking you to write me an equation. Now there are many other equations that would work because this is just a value, remember our a's in front, of 1. If I change that a value to 2 or negative 15, I'm going to get something that still goes through these zeros because it doesn't matter what number is here. Any number times 0 times any other number is still going to give me 0. So we're going to go just kind of simple. But do know there are more equations where there's an a value that's been multiplied through to all the terms, and they will also fit. So if you graphed y equals 2x squared plus 2x minus 12, if you graphed both of these in the graphing calculator, they would both cross at the x-axis at 2 and at negative 3, but they would be a little bit different. One would be a little bit steeper than the other. One would go a little bit further down than the other. They would still both have zeros. So I'm interested in the simplest one. This is what I'm interested in, where you don't have to do any other thinking beyond getting those values into the parentheses. But I do want you to be clear that there are actually quite a few more problems that also work. And this is what I do when I'm like, okay, I want them to graph this. I want to hit it here and here. So I pick those zeros, and then I might pick an a value that's not 1. And then try to get you to graph that. So that's what I do, and that's how I use it. But there are lots and lots of answers, but we're going to go with the simplest answer. Let's look at another one. We're going to write the quadratic equation with zeros at negative 4 and negative 1/2. So we actually have two options here. So remember, we're going to have x equals negative 4, x equals negative 1/2. And we've got to get those back into the parentheses. I'm going to put a y equals in front to remember that. Yeah, this needs to be an equation. So I know I have to have x's in here. Remember, it's just opposites. So this could be x plus 4, or it will be. This will be x plus 1/2. And then I can multiply them together. Y equals x times x is x squared, plus 1/2 x plus 4x, plus 4 times 1/2 is 2. So I could have y equals x squared plus, was that 4.5, 4.5x plus 2. You might be like, Miss Phoebus, I've never seen decimals in a quadratic. They're allowed. But there is a different answer that is allowed as well. So it's one of those things where it's like, if this is a multiple choice question or something, you might want to watch out. This might not be listed as the answer. Because remember, we can take this piece and we can bump it up in front. So I'm okay with either of these if we are like open-ended response kind of thing. I'm okay with either. So if I multiply those, I get 2x squared plus 2x. What am I doing? 2x squared plus x plus 8x plus 4. And I get y equals 2x squared plus 9x plus 4. So these are the same thing. Again, like in the last situation where I said they're going to cross at the same place, but they're going to be a little bit different. If you compare the two graphs, they are not going to be the exact same graph. But they are going to cross at the same location. So you're going to have something that looks like this. I'm going to pretend to draw this very poorly, right? So you may have one that kind of goes through and does this. And then you may have another one that comes through and does this. They have the same zeros. They intersect at the same place, but they're different graphs because they're different equations. They don't look exactly the same. All right, so we're ready for number 3. So that one had 2 answers. Which one do I prefer? This one looks nicer. If I was going to prefer one over the other, they're the same. But I do like the ones without the decimals, just a little bit. All right, number 3, we have a quadratic with zeros at 0 and 7/9. So because that's a fraction, we could write it 2 ways. Now with the 0, you could have x plus 0 equals 0 or x minus 0 equals 0, but really I want you to just write that as an x. And then this is going to be x minus 7/9 to get that back in the parentheses. And then really all you need to do is distribute the x. So we could have y equals x squared minus 7/9 x. Again, not my favorite. Or you could pull this up in front here. And then you could have y equals x times 9x minus 7. And that would be 9x squared minus 7x. This would probably be my favorite one, the one in the green. More so than the blue, but the blue is not wrong. You're probably going to see it more written in the green though. All right, now let's look at what happens when there's just one. So remember we talked about on a graph you could have 2 zeros, it could never intersect, but then there's also a chance that it could intersect one time. And we talked about that means that the 0 is the same. So even though this one looks like, x equals -3, there's one of them. It is actually, that parenthesis is squared. So that means that there's 2 of them. So we're in that boat. So we have y equals, and in this case it's going to be x. Now I have a positive 1/2. So when it goes in, it's going to become a -1/2 squared. And then you could write that out twice. Remember, with those fractions, you are going to have 2 ways to write it. So it depends on what you want to do. So I'm looking for both. So x squared, I have a -1/2 x and a -1/2 x, -1/2, and a -1/2 is a -1. And then plus a 1/2 times a 1/2 is a 1/4. I just multiplied those through. If you don't like that, especially with the fractions, dealing with those, you can pull that out in front and make this 2x minus 1 squared, where you are dealing with 2x minus 1 times 2x minus 1. And you get 4x squared. -2 and -2 is minus 4x plus 1, which is what you would get if you multiplied these all by the same number. Which is kind of, I like doing it. All right, so I want you to try number 5. See what you can do. Pause the video, write me an equation. So number 5 is just like number 4. There's 1 0. That's all that's given. It's not like the other one's missing. It's like what we're dealing here, where we have it just crossing one time or touching one time. So that means that we have a parenthesis squared. We have an x. We're pulling this -4 into the parenthesis. It has to change to its opposite, and the opposite of -4 is +4. And then I have x plus 4 times x plus 4, which is y equals, don't forget your y equals, so we're writing equations, x squared plus 4x, and 4x is 8x plus 16. How'd you do? All right, let's look and see what else we got. Oh, we got a table. So when you're dealing with tables, you have two options. If you see zeros in like the y, like multiple zeros, you can do what we just did. And you can pull the x's into the parentheses and change them to their opposites. I don't see two zeros. Okay, so we're not going to be able to do that. What we're going to be looking at here is vertex form. Y equals a x minus h squared plus k. And what we have to do is we either have to find the highest or the lowest value and be able to claim that that is our vertex. So let's look at number 6. Do we have a highest value or a lowest value? I see a lot of symmetry. You see this? Negative 11, negative 11, negative 2, negative 2. This is the highest that my graph is going to go. This is my vertex. Now, it's not always at 0. It can be anywhere else. But my vertex right now is at 0, 1. And what that means is that my 0 is in the h location, and my 1 is in the k location. H being here in my formula, and k being here in my formula. And what I'm going to do is I'm going to plug those values in. Now, I am missing, right now I'm missing a. So I'm going to leave a space for it, and then I'm going to come back and figure out what that is. So when I write mine, I write y equals, here's my blank space to put in my a value. Parentheses x minus 0 squared plus 1. Now, let's say for a moment that this wasn't 0. This was another number. Remember that when you go to put it in, you have to change it to its opposite when it goes inside the parentheses. Just like the other set of parentheses, it had to change its to its opposite to go inside the parentheses. 0 doesn't have an opposite. 0 is neutral. Okay, so I don't have to worry about the sign on that. But if you have to worry about it, when you figure out the vertex and plug that very first, that x value, that h value in, you have to change it to its opposite. Okay, now this piece can simplify. I can get rid of x minus 0 and just turn it into x squared. All right, the next piece that we're going to do is we're going to try to figure out what the slope is. What is the rate of change? And we're going to look for the next x over to the right. Okay, and what we're going to do is we're going to see what are we doing. So the change in y to go from 1 to negative 2, we're going to have to subtract 3 over the change in x to go from 0 to 1, we would add 1. So we are looking just at the slope for the next x to the right. And we're looking at a rate of change, remember, change in y over change in x, negative 3 over positive 1, or negative 3. Now, let's clean that up. We'll still have a negative 3 in the front. But we already talked about this x minus 0 squared can just turn into x squared plus 1. All right, so let's look at the graphing calculator. Remember in class I said if you're not looking and trying the graphing calculator yourself, you need to. So you can pause the video at any point in time, but what I'm going to do is I'm going to put in the equation that I just wrote, and then I'm going to go look at the table and see if my table on my calculator matches the table that I have on the paper. And if it's the same, then I'm going to be like, yeah, I found the equation. If it's different, then that means that I didn't write the equation. I need to go back and look at it. So let's look. We've got negative 3 x squared plus 1. And always double check and make sure you wrote your equation correctly based off of what you have on your paper. And then look here, 0, 1, which is what I've got, 1, negative 2, 2, negative 11. I'm feeling really good about this because this table on the graphing calculator matches my table on my paper. And you can use that, okay? Use this to help you check. All right, let's look at number 7. You ready? Can you figure out the vertex? I'm going to give you a second. The vertex is at 0, 0. You can see that symmetry. Now, you're not guaranteed to see always the symmetry. There should be some symmetry, though. So you might pick it up and the vertex is like, here, and like this piece is your last piece. That might be, what you're looking at. So you might not be able to see the complete full symmetry of everything. All right, so 0, 0 is our vertex. That means I'm plugging in a 0 and a 0. That's pretty boring. So let's see, y equals, we don't know what our a is. Leave it blank for just a second. X minus 0, we already looked at how to clean that up. Plus 0, I'm not really going to be able to write anything at the end there. Or I don't have to write anything at the end. I guess that's a better statement. Let's figure out the rate of change for the next x over. So to go from 0 to negative 4, I'm going to subtract 4. To go from 0 to 1, I'm going to add 1. That's a rate of change of negative 4 over 1, or negative 4. Let's clean it up if we can. Y equals negative 4. This x minus 0 squared is just going to become x squared. Plus 0, don't need to write that. Let's check. Let's check in the graphing calculator and see if we have it right. So there's my graphing calculator. I can go back to y equals, clear out what I've got, 4x squared, and then I'm going to go to the table. Second graph. And looky there. Negative 2. Ooh, did I not? Oh, I forgot my negative. See, it happens. Second graph. There we go. Negative 2, negative 16. Negative 1, negative 4. 0, 0, 1, negative 4, 2, negative 16. We're looking good. Okay? So just be careful because you can make a mistake like I did. Didn't type it in correctly. All right. Let's look at another one. Can you figure out where the vertex is? All right, so here's the vertex, but we also have these guys. These are zeros. So you have some options here. You can either write this in vertex form, or you can write this with zeros. That's the option that you have. So I'm going to kind of walk you through both ways. So for the vertex form, we have negative 1 comma negative 9. So we have y equals, and then I'm going to leave my little blank there, x. Now when I deal with this negative 1, I'm going to change it to a plus 1 squared, and then, oops, it's supposed to be a minus 9 because it's a negative 9. All right. To get the a value, which will be important for the thing with the zeros, we need to figure out what's going on with the next x over. So to go from negative 9 to negative 8, we would add 1. To go from negative 1 to 0, we would add 1, so our a value is 1. So that's the equation if you choose to do it in vertex form. If you choose to do it in zeros form, you still have to worry about the a, which we already know, but then you also get the zeros in there. So you have x, and you have x minus 4, oops, becomes plus 4, and then x plus 2 becomes positive 2 becomes negative 2, and then your 1 is still there. And you can multiply these through and get x squared minus 2x plus 4x minus 8, or x squared plus 2x minus 8. So you have 3 different formats that you could have your final answer written in, and we're going to check all of them in the graphing calculator. Why not? Remember yesterday we checked and we saw 2 parabolas that were the same right on top of each other, and that meant our answer was correct. Oops. Now we should, if we did it right, having a hard time. If we did it right, then we should be able to see 3 parabolas on top of each other. 1 blue, 1 red, 1 black. So let's get this in here. Y equals, I'm not going to put the 1 in, x plus 1 those are up, squared minus 9. And then I can even do the x plus 4, and that x minus 2, do that one. And then I can do the x squared plus 2x. So if you have these different forms, you can check if you're supposed to write it in vertex form, from vertex to standard or standard to factored or something, you can use this to help you. All right, we're going to graph. 1, 2, 3. Woo! So I have 3 forms for this table, and all 3 of them match. So I just need one equation from you. And the factored equation, I would rather not have. I'd rather see the standard form, so vertex or standard, but use the factored to help you get the standard form. Okay, so I want to see either this, and I'm looking for both, or this, and this helps you get here. Excuse me. All right, so number 9, we're going to pick, I'm going to have you pick. It doesn't matter which way, whether you choose the vertex or the standard. I'm going to show you both in a second, but pause the video, see if you can do number 9 by yourself. All right, here's your vertex. Your vertex is at -1, -4. So when you write this, there's our blank for A. The -1 goes in and becomes a +1 squared minus 4. All right, let's see if we can figure out A. So here we're going up 1, here we're going up 1, so our A is 1. So that is one way to write an equation. The other one is using these zeros. We'll have x plus 3 for this guy. Remember, it changes to its opposite. And then x minus 1 for this guy. And so we would have x squared, -1 and 3 is 2x minus 3. And we could check it in the graphing calculator and see if both of them are the same. Do we get that table? You know how to do that now, okay? But the question is, can you write an equation based off of the table? I hope so. You have 2 methods. All right, what are you going to do for a graph? Well, you have the same kind of thing. You have a vertex. If the vertex is nice, which in this case it is, you could use that. But in some cases, you also have the zeros. So it depends on what you have and what you're going to use to write it. So it's a personal preference kind of thing. I'm going to be looking for both. So let's see. If we were going to do the vertex is located at 0, -4. So we would have y equals, we're going to leave a blank for A. Remember, we got to check for that. X minus 0 squared minus 4, which remember we talked about simplifying. And then you always want to go from the vertex, you want to go up and to the right. So we're going to count slope. Up 1, right 1. So the slope is 1. Try to keep it basic for you, at least a little bit. So this can be written as x squared minus 4. So you could write it that way. And that's actually already in standard form. If you use the zeros, let me switch colors, we're going to do the zeros. You just have to get them back into the parentheses. So x, this is a -2, so that becomes x plus 2. And x, this is a +2, so that becomes a -2. And then when you multiply them, you get x squared. +2x and a -2x, it's going to cancel, minus 4. So you get the same thing regardless. So it depends on what you have. And I want you to practice with both, because sometimes the vertex is not very nice, but the zeros are. And sometimes the zeros are not very nice, but the vertex is. So if you're good either way, then you're going to be good to be able to write the equation no matter what. All right, so let's look at number 11. You want to pause the video? You want to try it? See what you can do. All right, here's your vertex. Your vertex is at 7, 1. So if we were going to write this with our vertex, x minus 7 squared, remember it has to change to its opposite, plus 1. Your a value, we're going to go down into the next x to the right. So I'm going to go down 1, right 1. So our a is -1. So we're done in vertex mode. If we're going to do zeros mode, you still have to use that -1 that we just found for A, but you can pull the zeros in as x minus 6 and x minus 8, and then you can distribute that -1, and then you can FOIL and get -x squared. What's that? Plus 8 plus 6, so that's a 14x minus 48. And then you can go and graph either of these. In the graphing calculator, compare it to the graph that you were given. Are they the same? Do they look similar? And then sometimes you can catch, you can be like, oh, A isn't 1. I need to flip that upside down. A needs to be -1. Get that reflection in there. All right, so here's a couple more. Why don't you pause the video, see if you can write an equation. All right, for this one, we have a vertex at -1, 8. So y equals x, change that -1 to a +1 squared plus 8. And then let's look at our a value. We're going to go from the vertex to the next x over. So the next x over is here. So I'm going to go down 2, right 1. You always want to go right 1. So if I go down 2, right 1, that is a slope of -2. And then we would be done for our vertex. If we were going to do the zeros, we still want that -2. We have 2 nice zeros, so this would be a good place where you could use that. A -3 becomes a +3, and a +1 becomes a -1, but then you have to multiply them together. So -2x minus 6, x minus 1, so y equals, is that -2x squared? I have a +2x, and a -6x is a -4x plus 6. We're just multiplying there. So either of these, this one or this one. I kind of like the vertex because there isn't a whole lot of work. I don't have to keep writing it out. Now I am going to show you in a little bit how to go from this mode to this mode. But right now, we can leave it either in vertex or we can get it in standard. All right, here the vertex is 1. So that would mean that y equals x minus 1 squared, and it's 1, 0. So plus 0, but I don't really need to write that. Let's look at our a value. We're going to go up 1, right 1, so that's going to be an a of 1. So we could just write that as y equals x minus 1 squared, which would also be the zeros portion. So if we wanted to multiply that out and get standard form, we could. X squared, -1 and -1 is -2x plus 1. So there's the standard form of it, but the vertex form is right there. All right, so there's more. There's always more. So you want to try this one, see how it goes? All right, so on number 14, especially if you're looking at the vertex, here we've got 3, 1, and then you start thinking about the a value. The a value doesn't quite, here's the, like the next full point, like to go up 1, right 1. You see how a vertex misses, or the a value doesn't quite have a slope of up 1, right 1. So we're going to have to come up with something because there are no zeros, none. And what we need to do is we need to figure out what that a value is. So a lot of times when it's not 1, and you can see that it's going to be kind of in between, we're going to have to look at maybe a fraction, probably a fraction. Okay. Most of the time it's a half, but you're not guaranteed that. But let's go ahead, let's just play around with this like it's a half. So y equals 1/2 x, and then that would be a -3 squared plus 1. And let's see. Might work. It might be more like 3/4 because to go up a half and write 1, I feel like we're even missing that. So you might even put like a 3/4 in there. That might be a little bit better, especially if we're checking. You might want to do that. 3/4. There's some fraction in there. Now you might be like, Miss Phoebus, this is not very accurate. I'm gonna be like, yeah, guys, I know. But there is a way on the graphing calculator to be able to feed it points and to tell it to write the equation for us. But we're not there yet. So we're going to just kind of estimate and see. But on your tests and things like that, it's going to be more precise. You're going to be able to tell what the A value is. So I don't want you to forget, but I did want to talk to you about a few examples like that. All right, let's look at 15. The zeros are not very nice on 15. You see that? So we have to be able to do vertex form. And our vertex is at, what is that, 3, -6. Our A value is nice. You can see it in the points. So we're going to be able to use an A value of 1. So y equals 1, if you want to. You don't have to. X minus 3 squared. I don't know why I keep trying to change the outside one to its opposite. Badness for this. -6. All right. Now, I'm going to show you in a little bit how to change it from that vertex mode into standard form in case you need that. All right, but here's more. There's always more. We're gonna go ahead and move on. If you need some more practice with these, you have these available to you. If you want to talk about them, we can. All right, so we're going to be able to write the vertex form of a quadratic in standard form. We're going to be able to use completing the square, and I actually have another method that you might like better than completing the square for the skill 60 to get it to a vertex form. But we'll also focus on something that we worked on yesterday too. All right, so page 185. And on page 185, we're going from vertex form to standard form. So here are the steps. You're going to multiply the perfect square binomial. Remember that x minus h squared represents 2 binomials. But you're going to keep that, when you multiply it out, you're going to keep it in parentheses. You have an a value in front, so you're going to distribute the a if necessary, if there is one. And then you're going to combine like terms and write in standard form. So what I'm talking about is, remember that I can write this piece as x minus 2 times x minus 2. I want to multiply those out. So this becomes, and here's where I'm saying keep your answer in parentheses, and we'll talk about that in a second. X squared minus 2 minus 2 is a -4x. -2 times -2 is a +4. Now, if there was an a value in front, I would want to distribute that, but my a value right now is 1. So distributing a 1 isn't going to change anything. So I have x squared minus 4x plus 4 plus 6, and then I have some like terms I can combine. Y equals x squared minus 4x plus 10. Now let's say you don't feel 100% confident. You can take this and plug them into y equals and compare the graphs. The parabolas should be one on top of the other. You just have to plug them in to check and see if you did it right. All right, let's look at number 2. So the very first thing we're going to do is we're going to write those parentheses twice. There's 2 of them. All right, this one does have an a value, so I'm going to save that and distribute it in a little bit. But if you are one of those people, because I was having problems with people in the past trying to distribute that through like to the other set of parentheses. So if you're okay distributing it into the first set, you could go ahead and do that. If you don't like doing that and you just want to multiply your parentheses together, you can do that as well and distribute later. So that ends up being 3x squared minus 9x minus 9x plus 27 minus 12. So I get 3x squared minus 18x plus 15. And there it is, standard form. So that's all we're doing. We're multiplying two parentheses together, we're distributing the 3, we're combining like terms at the end. All right, you want to try number 3? Pause the video. All right, let's see. We've got -2, x plus 1, x plus 1, plus 3. Let's just multiply. I'm going to just multiply mine together with the parentheses first. So that's going to be x squared, 1x, and 1x is 2x, plus 1, plus 3. As long as you're following order of operations, you should be good. So I distributed my -2, and then I'm going to combine my like terms. Y equals -2x squared minus 4x plus 1. How'd it go? This A and this A should be the same A. So don't be like changing that up. All right, let's look at 4. Y equals -3 x minus 4 times x minus 4 plus 7. Let's distribute that -3 just into the first parenthesis, though. Don't go crazy. So then now I can FOIL. So I have, I don't need my parentheses anymore. -3x squared plus 12x plus 12x minus 48. And then I'll combine my like terms. So I get -3x squared plus 24x minus 41. Okay, so that's all we're doing, multiplying here. All right, now, there are 2 ways to do this. You can complete the square, but there's a small problem with that, especially if there is an A value that's not 1. So the easiest way to go from standard form to vertex form is to calculate the vertex. That is the easiest way. So how do you find the vertex? X equals -b over 2a. That's different than the completing the square formula. Once you have that, that is the piece that goes in there. Then you need to get the y part of the vertex, and you get that by plugging in the -b over 2a back into the original form. And once you have that, you're going to actually substitute the values for A, H, and K. Now, the A piece, you don't have to do any work. You get to steal. I love stealing stuff from math and plugging it in somewhere else. You get to steal the A piece and plug it in. So no worries there. The other piece that you have to work for is the H and the K. All right, so you need to work on finding that vertex, which is good work. Some of us are still struggling with that. So let's make sure we can figure out what the vertex is. So what I like to do for these is I like to come down here and I like to put in some blanks. This is just me. And then I can change this x minus to a plus really easy if I need to. Okay, so let's find the A value. What's our A value? See here? A value is 5. Guess what's going in that blank right there? 5. Love that kind of math. All you gotta do is know where to look. All right, the rest of this is vertex. So how you find the vertex? X equals -b over 2a. We're looking at a -10 over 2 times 5. A -10 is 10. 10 divided by 10 is 1. So this is a positive 1, but when it comes in here, it becomes a -1. So I should see -1. All right, we got to plug 1 back in. So that's 5 times 1 squared minus 10 times 1 plus 37. 5 times 1 squared is 5. Minus 10 times 1 is 10 plus 37. 5 minus 10 is -5. -5 plus 37 is 32. A positive 32. We couldn't complete the square on this one because A is not 1. You can't just throw it away and say, oh, well, I already know what A is. Now let's complete the square. That doesn't work either. So finding the vertex is the best method. So let's set this up. Y equals blank. x minus blank squared plus or minus. That's why I didn't put the sign in. We don't know if it's plus or minus yet. Blank. First thing, let's steal the A. A is 7. Or steal it and shove it right in that blank, right there, 7. All right, next up, let's find the vertex. Vertex is x equals negative b over 2a, negative 28 over 2 times 7. 2 times 7 is 14. That is negative 2. So when I go to plug a negative 2 in here, it turns into its positive, so it turns into its opposite. The opposite of negative 2 is positive 2, so I'm going to change that into a plus 2. And then now I've got to plug in a negative 2 into my equation. Do a little bit of math. So this is probably the hardest part. I forgot my squared. Try again, come on. Okay, here we go. So 7 times 4 plus negative 56 plus 19. That's 28 minus 56, which is a negative 28. Negative 28 plus 19 is is that a 9? I think it's a 9, a negative 9. And then you can check. You can graph this, you can graph this. Do they match? Do they line up? If not, then we've got to go back and fix something. Maybe we have a wrong sign or something like that. All right, so we're still finding vertexes. You can keep practicing, but I want to try to keep this shorter than what it is right now. So we've got one more thing to do, which we've already done. So we're just going to do another little practice of it because this is the one that people get stuck on the test. So we're going to move the constant to the other side of the equal sign, and then we're going to complete the square to rewrite the equation. So we're going to do a couple of these, and then we'll be done. So the very first thing we're going to do is we are going to move that constant, subtract 4. And this is, remember my blank system? We're going to fill in some blanks. Negative 4 plus blank. All right, we're completing the square. What do you do to complete the square? B divided by 2 squared. And B is negative 10. So remember, don't confuse this with the vertex form. That can happen. Negative 5 squared is 25. So we're going to add 25 to both sides. We're going to rewrite this as something squared equals, and in this case, there's a 21. And that's going to be x minus 5. Because that's a negative 5, I can steal it and bring it down here. We'll do one more, and then we'll wrap up the video. Okay, but that's a lot of writing and rewriting. Okay, so let's look. We're going to move the constant. X squared plus 28x plus blank equals 13 plus blank. How do we figure out what goes in the blanks? We do b divided by 2 squared. 28 divided by 2 is 14. 14 squared is 196. Fun times. All right, so our parentheses look like x plus 14 squared, and then 196 plus 13 is 209. All right, ladies and gentlemen, we're going to stop there. You have some extra problems in your notes that haven't been worked out. You can use that to help get ready for your test. If you want to try them out, check yourself, you can. You can take pictures of them and email them to me, something like that. All right, there's an open Google Meet today that I'm trying to hurry and get to. So if you're watching this video and you need some help with something, don't be afraid to stop in. I am going to stop for lunch, so we're going to do, probably not going to start at 8 exactly, probably more like 8:15, but you're probably not watching this until after 8:15. And then we're going to go to probably about 11:30. And then I'm going to take a break for lunch, and then I'm going to try to be back about 12:10, 12:15, and then go to about 3 o'clock. Okay, so that will be the times for the Google Meet today on Wednesday. All right, I'll see you guys in the next video or tomorrow. Have a good day. Bye.